Okay, for people watching on the live stream, yet another in our series of incremental language development, internal design meetings, getting ready for the freeze of the next version of Wolfram Language, which is supposed to be happening tomorrow. Some of these things will not be relevant to that. We were just talking about what has become an old, if spicy, chestnut, the naming of the function curry. I think we're not going to solve this right now. Let us try. I really had wanted to have a chance to think about this. I have not had a chance to think about it. I would really like to have a name that can, if somebody sees it in a piece of code, that they understand something about what it is without having to ask the question. But I'd like to ask, what would be the elevator version of what does curry do? So if you see, okay, not the elevator version. If you see, somebody sees curry of f of x of y, okay, or they see partition of, this is much more obscure. The curry second partition 3 comma list, range of 20 or something. Okay, what do you tell somebody about what that does? How do you explain it? Anybody want to try that?
I think it's easier to explain what curry second partition 3 does. It's a function that will do something with an argument.
Good, fantastic. Okay, try.
No. Yes, no. I'm trying first to eliminate the range 20. So curry second partition 3 is an operator form of partition that will. It's an operator form of partition that will partition an expression in.
You don't get to use that though, because this is going to be general. So you don't get to say partition. We got a bunch of background noise. Could whoever's got background noise mute, please? Thanks. Okay, go ahead.
Yeah. So if we have f, so it's an operator. It's an operator form of f. Well, it would be curry second. We're talking about curry second.
Well, even the curry, even the regular curry.
Yes. So. Yeah.
Okay, so this might be curry of f is an operator form of f that sequentially how many arguments does it accept?
By default, 2.
That's pretty useless.
Well, remember that before we had curry f representing the swapping.
I know. Well, it makes more sense. But honestly, it makes more sense to default this to 1 argument.
To 1.
It's kind of stupid then, because then curry of f is equivalent to
f.
Right. But then how do we do it? We can't default it to as many as you give, because that doesn't make sense either, does it?
Exactly. Yes, we cannot do that. We need to know at the very beginning. But I think 2 is the most frequent case. Most of our current operator forms have 2 arguments. And we carry the
Yes,
second.
I understand, but they typically do a curry second in that case.
Exactly, yes. I'm thinking that, swap arguments sounds reasonably nice. We could have curry arguments.
It doesn't help us. It really doesn't help us. It's still completely obscure, because what you see is curry. If we said swap arguments, someone on the live stream, Swishcar, is suggesting curry equals conjunction bond. What does that mean? I do not know what that means. Anyway, yeah, I don't know what that means. I'd like to know what that means. Okay, we're going to burn all of our time talking about curry here.
Yeah.
Look, worst case, which is kind of silly. I mean, it seems crazy to put this in as a function in the experimental context because, well, we actually can't figure out the semantics either. Not only do we not know the name, we don't even know the semantics. Although I have to say that curry as a thing, by the way, this is incorrect, that first line there. That's the swapped form, right?
Yes, this hasn't been updated.
It would be lovely if we could come up with a name where the default case, because the default case is otherwise not useful. The one argument case is frankly not useful. I mean, okay, so here's a weird name. Sequential operator. It's a totally weird name. But, you know, a sequential operator form of blah that accepts. Okay, let's try. Let's just say, okay, because we're is a sequential operator form of F that such that of y of x is f of x of y. And then we get to say, you know, sequential operator, comma, you know, comma 3, 2, 1 is a sequential operator form.
Why is the default reversing those args?
Because it's not useful otherwise.
Yeah, there'd be some, yeah, there's three.
So it's head, then arg2, then arg1, 0, 0, 2, 1.
That's correct, because it's not useful otherwise. Otherwise, all it's going to do, otherwise it's a very arbitrary two-argument thing that I don't think is very useful. Wait a minute, that accepts that assembles a function from a sequence, because that's going to assemble something. That particular thing, curry 3, 2, 1, will take the first thing that it gets here, right, and put that as the third argument. Is that correct?
Yes. It will permute the arguments before applying F to them.
So this is X, Y, Z. We'll give, could whoever's on got background noise, please mute. We'll give that, right?
Yes. Use a more interesting permutation like 2, 3, 1, which is not its own inverse. And then, yes, what will this give?
This.
Exactly.
Yeah.
Exactly.
Okay. Well, here's another weird name. Operator template. No, that's not right either, because our template functions don't do sequential stuff. That assembles a function by sequentially assembles an expression from a sequence of function applications. Is that what it is?
In a sense, I mean, it doesn't refer to the fact that the arguments are being permuted.
See, I'm wondering whether construct, whether there's a way to think about it in terms of construct. Or something, some word related to construct. Like operator construct. Or sequential construct. Okay, let's try this.
What about just assemble?
I was thinking about things like that, but I think that that's too obscure a word. Construct, assemble, nobody's going to remember which does which. I mean, I suppose that's really weird. Curried construct. It's like it's a stir fry.
Yes, construct doesn't feel like a verb here.
Right. Well, and it doesn't need to be a verb here. I mean, it's a sequential construct, concentric construct. On the live stream, Swish Car is suggesting function bond. I don't get that. I don't really think, unfortunately, I think and I think, you know, curried function doesn't really do it either, because it's just, there is a right name for this and we don't have it.
Well, we probably should discuss.
Yeah, let's not burn all of our time on this. Let's go to the other items that we have to deal with.
Yes, so we have two new functions that are implemented.
Okay.
Not yet merged, but the design seems clear.
Sequence split.
Yes, so this function is aligned with sequence.
Didn't we already go over these?
No, we reviewed it sequence replace last week.
Okay.
And this function is basically aligned with sequence split and sequence. We don't have an implementation. If you're going to try it,
we do. We do not.
We do not. We do not yet, right, Xavier?
It's not in Xcanable.
No. So it's basically like a string split, in the same way that we have extended the string functions to sequence functions, sequence cases and sequence replace. This is the split function.
Yes. And I agree. I think this is, we discussed this, right?
Yes, yes.
Splits at a pattern. Looks right to me. What does it do? It splits into most end sublists, not splitting the latest stuff is the basic point.
Yes. So this is like sequence replace, which is able to do end replacements and stop.
Right. Okay, fair enough.
This is imitating string.
Okay, I'm good with this. Did we knit it?
With the other sequence functions.
Okay. All right. And we probably should knit it with split and things like that. Right. We could do a final knitting, but we don't have to do that right this moment. Okay, let's look at nearest to. We've looked at this before, haven't we?
A bit, and we discussed some details by email. Basically, this is just an operator form aligned with greater than, etc., and equal to.
Yeah, let me just check one other thing. I mean, nearest is starting to have these string arguments, right?
Yes, this is inheriting that.
Okay, so this nearest to, I see.
So if the data has that, then it will work, because this is just a converter to nearest.
What about this form here?
Yes, that's the second line. Well, n is here meaning both n and n comma r. We were discussing whether
we should probably document that.
Okay.
But I think, yeah, right. This is not talking about the use in entity lookups, which I think is an important use.
Yes, we are working on that. We have discovered that we have an issue with quantities, because nearest is not very nice to all be in quantity.
I see. Okay.
So
well,
if we specify explicitly distance function is a quantity magnitude, then it works. But
well,
it should be
correctly. Okay.
Exactly. But then it will work.
Did you notice, by the way, that horrible bug in the cloud that I reported today with quantity array?
Yes. So that's a generic. It doesn't have to be. It's not related. Sorry, to geo-elevation. It's a generic thing of the new mechanism for storing data in arrays. So if you do sparse array of a large range, say.
Oh boy. Okay. Is somebody looking at it?
Yes, I reported it to Lou, and Lou knew it, and there is a cloud ticket for it. So they are looking into it.
Okay, good. All right, let's get to the main event here, data representation and data set.
Yes, so this is a continuation of the discussion we had last week. In the last discussion, we were talking about a constructor of nested associations. So Tony has pointed out that it would be nice to have a lazy version of that, a container, not a constructor. And thinking about it, we realized that it would be also very useful for data set. This is the idea of a lazy data set that you have also pointed out sometimes.
Okay, so let's walk through what we're talking about here. So the issue is we've got a list of lists, for example, and we want to associationify the list.
Right, by providing
keys based on, okay, so the name association array has been floated as a possible name for that, as has a generalization of association thread. Is that correct?
Well, the idea of association array would be the lazy version, the version that contains the data, but does not construct an actual nested association. Because Tony points out that it takes quite a lot of time to construct that association. So if you are just going to extract some data from some value using keys, we can do that by working directly on the array.
Interesting.
It's a bit the idea of quantity array, in which we could construct a large array of individual quantities. But
this is an interesting idea, yeah.
Okay. So
Okay.
the headers play the roles of the units.
Interesting. What happens if you want to mix those two ideas?
Well, Tony was suggesting that why don't we also do this via structure array? I'm a bit worried that we are going to construct a competing object with data set, because both will take arrays with keys in at any level. So I would prefer to have this object, but to hide it inside data set.
So your proposal would be to have data set be, so one possibility is to have something where we have data set and then we have the headers specified in data set.
Exactly, yeah, either another argument or options. Because we don't know what's going to be the most important thing to have in data set second argument. It could be types in the future or something else. So perhaps an option is safer. But yes, we do need to have the ability to specify this. And then instead of constructing internally a nested association, which will take quite some time for large cases, we just keep it as it is. And we know how to extract information.
Yes.
And then this will be faster.
Okay, but that's not solving the problem of, and then what would you do? You do normal of that to get out the thing with the actual nested associations?
Yes, or we could have a function that does that, the constructor we were talking about last week.
Which constructor? The association thread type constructor.
Exactly.
Wait a minute. Okay. So look, there are two issues here. One is this notion of a lazy version of this. I mean, in a sense, it's dataset's business, how it chooses to, I don't know. I'm not super happy with this. I mean, okay, so
I think that because a data set is even atomic, it doesn't matter how it's internally storing the data, as long as it always returns the expected result in any operation. So if the user is passing the data already as a nested association, we leave it like that. If the user is giving us the array separated from the headers, why reproducing again and again and again all the internal headers? That's a blow up in memory. And Tony has some examples in which with even a top level implementation, he gets speed ups of 100.
From what? From
nested associations. Because it takes quite some time to construct the nested association from the arrays. Tony, do you have comments?
Yeah, basically what you said. Correct.
Okay. Well, okay, so we've got the non-lazy version, the immediate version, which is more of a key distribute type function. I mean, it isn't really headers, it's really some kind of keys.
Yeah.
What are our key related? I mean, I suppose we could have a thing, you know, key lists or something.
You had the idea of having association thread itself doing this. It's a bit of
no, but this I'm talking about for the data set case. If we're going to, you know, have a way of specifying this lazily in data set.
Oh, you're looking for the name of the option.
I'm looking for the name of the option. Are you saying that association thread could do this in the non-lazy case?
Well, you suggested to have a list of lists of keys in the first argument, and then each sublist would apply at a different level. And this may work. It's a bit of an extension of our concept of threading, but this could work.
Well, how would you distinguish keys that are lists?
By using the head key, if needed.
Fair enough. I mean, you could also give a third argument here, which specifies with some kind of level spec.
Could be. That would be actually very thread-like.
Right. All right. I agree that that's a reasonable thing to do, to generalize this to allow lists. Does it go the right way around? I mean, it's a little weird, right? It's no, this doesn't work. This isn't the threading operation.
Yes, that's what I'm saying. It's not truly a thread operation as we have it in other function, because it works at several levels at the same time.
I personally prefer key distribute.
Distribute. Well,
isn't it a distributive type operation?
Well, again, we have the same issue. Distribute also works at the same level of the expression. It's distributing an operation over another operation. It's a bit like a transposition in which the first two heads are different.
What? I don't understand that one.
Yes, like we do when we do distribute plus over times or vice versa.
Yes.
It's like changing which head is more internal and which one is less internal. But it works only at two levels. Well, we want this at multiple levels.
Right. Well, what function does that? What function other than map goes down and applies things at many levels?
Well, that's why I was looking for a nest here.
I don't think it is a nest.
It is not a nest, but this multi-level.
Right. I mean, nest is doing the same thing, or a fold. You were also talking about a fold at one time.
Yes, but I meant really nest. But it's not, again, yes.
Nest. I don't believe in nest in this case.
Yeah.
I think, what would we say if it was key distribute? We would say something like distributes the key ij at level I in the array. Distributes, no, uses the key ij, creates a nested association structure in which the key ij are the keys at level I. Correct?
Yes.
So the function association itself takes just a list of rules, and this would have no such thing. This would be literally a list of, so this is a thing. Wow, this is a different kind of operation than we've had before.
Yep.
What's an operation in which what this has to do, this is a mapping from dimensions. These things have lengths which are the dimensions of the array.
Correct.
I mean, there's also apply keys.
Prepend keys.
I don't believe in prepend because it's really not. It's more like it's using those keys.
Yeah.
By the way, does anybody know if we have a place to store this?
I don't remember. That's the sort of thing Shushma remembers very well.
Right. Who is somebody filling in for Sushma?
I'm taking notes, but I don't know where you normally keep your files offhand without looking.
Okay. Humph. Well, let's see if we have a section here for data set. Okay, so we're going to put this in association thread, etc., under the data set.
Yep, I got it.
Area. Okay, so that whatever this is, okay, so then there's also the lazy version with data set itself.
Right.
Is this an end user construct or is this something more for, I mean, how is this going to work? Is this really going to be an end user thing?
What do you mean end user?
Well, I mean, as in, are people going to get data sets that have been prepped this way, or are they going to create them?
I expect both. I mean,
Okay.
imagine an array which is a packed array of integers, say. So blowing it up to nested associations will lose the packing. and it's going to take a lot more memory. So there may be cases in which it's more useful to prepare data sets in this way.
What are the competing second arguments of data set?
I'm not sure, yes, but I mean, I imagine that type information could be important to provide at some point.
The problem is that having a you know, I just don't, I mean, key lists is about the only thing that I can think of. And then we could imagine apply key lists. Key lists, arrow, whatever, inside data set, and then apply key lists to do the actual things on an array. Making sense?
So, Tony, do you see advantages of having a separate construction here, this association array you were proposing?
So I was wondering whether it could be more efficient if there's a dedicated function, but given how associations or lists of them are represented in memory, that made me think we might need a lazy version.
Well, I'm sorry. The question of whether what Jose is asking is the custom association array for some reason better than a data set that has been annotated to use this?
Yes.
Are you answering that it is, or are you answering that that's the question? Jose, are you saying that you agree that that's the question?
That's the question, exactly. So sorry, I thought you were asking Tony.
No. So
yeah,
Tony,
so I don't know which one is better. For me, currently it's an implementation detail, but
okay. I mean, association array is nice in terms of, you know, the fact that then we could conceivably just have association array is just a lazy version, and the operation that we're doing, then we wouldn't have a specific function for it. It would just be normal of association array.
yes. And one thing I imagined is having keys not at all levels, but at some levels, just a list, which could be represented.
I agree. So I mean, that's going to be headers. It's going to be keys at one level. There'll be a key list 1, and then there might be an automatic.
Or none.
Yeah, none is right. Key list 2, etc., etc., etc. And automatic, what would that do? Would it, for example, do sequential integers for the association?
Therefore, we already have the position.
What?
We already have the position, so nothing is needed. You can still extract it using an integer.
If we did it that way.
Yes, but the normal form will be different. So perhaps Stephen is right, and automatic would insert 1 goes to something, 2 goes to something.
Right.
Now, the problem with a new construction is that if this is going to be an array, we have to work quite a lot to propagate it everywhere. And Tony was initially suggesting to reuse structure array like quantity array did, but this is another case in which it feels a bit of an abuse.
I don't know. I mean, that's a question of, I don't really know what, I mean, structured array.
The word might not be right because the array defs
possible. I mean,
of a nested list of a nested structure of lists and association. It's not an array actually, because the head has to match.
Well, you're saying that the name should actually be array association, not association array. Is that right? Because you're saying it's really an association in the end.
No, basically array defs would stop wherever the list of the structure list would start being different. So if it has 3 key lists and then a none, the array depth would be 3 instead of going down the whole structure list.
I don't understand. The array depth, look, the array depth, it's not an array anymore. If it has a an association, it's not an array anymore.
But if it's purely association, wouldn't it be an array?
Not really.
Not really, no.
So, yeah.
I mean, therefore, array association might be a better name than association array.
But
Yes.
array depths of association nested gives 2. So by this definition.
But if we call it array association, then it's not a natural type of structure array. We would have to implement it independently, and it's going to be a ton of work. While having it inside dataset has already most of the interaction with the rest of the world prepared.
Yes. But then, okay, then that again raises the question, does one want a non-lazy form? I mean, so, okay, so we've got key lists and apply key lists. Is one possibility for those different names.
I have the impression that these are independent problems. We can still have the new form, the internal form of dataset, independently of whether we create this external object called array association or association.
I agree, but I'm not suggesting that. I'm suggesting apply key lists just does the thing, producing an actual nested association, nothing lazy, right?
Right. Yes.
Just
yes.
does the operation.
Yeah. Yeah. Mm-hmm.
So I mean that would be a family, a pair. Key lists would be the. I'm a little troubled by that because key lists to me might more be an accessor function that gives you the lists of keys at each level.
Yes.
Like you might want, you know.
Yes, like edge list.
Yeah, what gives the list of keys at each level?
Is keys able to go deeper?
It's listable.
Listable, but if you have nested associations, is it able to give you the keys at all levels of the nested association?
No, and that also might not work if the associations are not rectangular. So
I unfortunately have to go here. Well, you guys can chat about this a little bit more. This is clearly not an 11.3 issue.
Right.
But we need to, yeah, right. My preference would be to say, okay, it looks to me like there are 3 things that are needed. Potentially, you know, either a lazy construct of its own that can be inserted into dataset, or a way to specify this within dataset, an accessor function that inverts, well, a constructor function that takes key lists in an array and turns it into a nested association, and the inverse of that takes a nested association and extracts the key lists from it. Mm-hmm. And I have to say, key list seems like a pretty good name for the extractor.
Yeah.
So an apply key list seems like an okay name. For yeah, so key lists, that's kind of like dimensions, and the function that applies dimensions to something. Wow, what is that? We just introduced a new function for doing that, right?
Are you thinking of reshaping, array reshape, or?
Yes, but the function that take list.
Take lists.
What does array reshape do now for this? That is,
It's keeping the same elements, but with different dimensionality. It's basically like flattening and then unflattening to different dimensions.
oh right, I always forget this function. Does it refer to take list here? It certainly should. Oh, whoops, we need to add that. Don't you think?
Yes, well, take list is an extractor. This always returns basically the same object, just in a different.
I know, but okay, so whatever we are doing here, this should be referring to array reshape for sure.
Yeah, yeah.
Array. I mean, you know, we thought about names like array relabel, but I don't know what label is. You know, we could call it labels instead of keys, but we call them keys.
Yes, I think keys is better. Yeah.
Let's see. I need to go. I'm sorry. I need to go. All right. To be continued, guys.
Okay.
All right. See you later.
Yeah.
Bye.
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 Bye.